is about horizontal tangent. So what is horizontal tangent? Horizontal tangent means the tangent line is a horizontal line. So let's say we have a parabola that looks like this. At the vertex, this point, the maximum point, the slope at that point is equals to 0. So that means the tangent line looks like this, is a horizontal line. What is the slope of a horizontal line? The answer is the slope of a horizontal line is 0. So before I start solving this problem, if you think my video is helpful to your learning, please give me a like and click the subscribe. I promise it is worthwhile to coming back to visit my channel. Alright, so we have this function f of x equals to e to the x sine of x. I am looking for at what point does the function have a horizontal tangent. So every time you hear the word tangent, the first thing you got to do is you have to find the derivative. So f prime of x. So since this is the product of e and sine, we have to use the product rule. The product rule is fg prime plus gf prime. So this is e to the x. The derivative of sine is cosine, and then plus function g. The derivative of f is still e to the x. It doesn't matter how many times you take derivative. Now, that brings you to the next interesting question. Horizontal tangent, the slope is equals to 0, right? So at this line, the slope is equals to 0. But how do you express that in your works? So to express that in your work, all you have to do is you have to set the entire slope equals to 0. And then you have to solve for x. So the way I solve this equation is I factor out e to the x, and then I have cosine x plus sine x that is equals to 0. And then the next step that I would like to do is I am going to apply a zero product property. Zero product property says you have a times b equals to 0. That means either a equals to 0 or b equals to 0, or they are both equals to 0. But a warning, in order to apply zero property, the other side must be a 0. If the other side is anything other than 0, like a 1, a -6, a 10, then this property is not going to work. So this only works if the other side is equals to 0. This side is equals to 0. So you have e to the x equals to 0. This one has no solution, right? I will explain why in a minute. So cosine x plus sine x equals to 0. So solving this one is pretty interesting. That's why I bring this problem up. So we have sine x equals to negative cosine x. And then we divide both sides by sine. So 1 equals to negative cosine. Oh, actually, I don't want to work with the cotangent. Let's divide both sides by cosine x. So we have sine x divided by cosine x. This is equals to -1. And then we have tangent x equals to -1. All right, how do you find a tangent x equals to -1? So here is the logic. Tangent x is equals to -1. Back to trigonometry, tangent is y divided by x, right? So in a unit circle, you pick any point, and then you take the y coordinate divided by the x coordinate. The result is negative. That means you either have a positive x, negative y, or you have a negative y, positive x. So in what quadrant do we have this? This is my xy plane. So in order to have a negative x and positive y, that is only possible in quadrant 2. To have a positive x and negative y, that is only possible in quadrant 4. Okay, so we have a point right here and a point right here. So what point is that? Do you still remember this? At pi over 4. In the first quadrant, we have root 2 over 2, comma root 2 over 2. If this doesn't ring your bell, you have to review your unit circle. So look this up online. Unit circle. Unit circle. If you don't know what I am talking about, you have to review your unit circle. Unit circle is not a problem that needs to be require a deep discussion in calculus. So this is pi over 4, and what coordinate? What's the angle do you need in quadrant 3? The answer is 3 pi over 4. At quadrant 4, we have 7 pi over 4. So in quadrant 3, we have a negative x and positive y. At quadrant 4, we have a positive x and negative y. So that gives me two answers. X is equals to 3 pi over 4, and x is equals to 7 pi over 4. And then at this point, this one has no solution. Two ways to explain this. First, e is around 2.7. 2.7 raised to what power is equals to 0? That is impossible, right? You multiply 2.7 to itself a few times to get a 0. That is impossible. So that is the first way to explain it. The second way to explain it is you recall the graph of e to the x, which looks like this, is an exponential function, and there is a horizontal asymptote at y equals to 0. That means it doesn't matter what x you pick on this side. So as either you pick a negative, like negative 100, so you will never get y equals to 0, because as x moves to negative infinity, the function is approaching to 0, but will never equals to 0. So overall, we have two answers. At 3 pi over 7, 3 pi over 4, and 7 pi over 4. So this is only if x is between 0 and 2 pi. So sometimes the problem can ask you more than that. Sometimes they ask you to generalize your answer. How do we do that? So the trick in this is I have x equals to 3 pi over 4, right? I am at quadrant 2 right now. How do you jump from a quadrant 2 to a quadrant 4? The answer is you have to add a pi to it. So I am going to add an n pi to it, and I have to specify that n is an integer. So when n is equals to 0, you are at pi over 4. When n is equals to 1, you jump to 7 pi over 4. When n is equals to 2, at 7 pi over 4, you jump back to the 3 pi over 4. All right, so that will be all for the horizontal tangent problem. I will see you all in the next lesson.